Yeah, that sounds interesting.
Hi, everybody. All right. Good evening, everyone. I'm glad that so many of you could join on a Sunday night, so thank you for coming. So today, Sam's going to be doing part 2 on his lesson on Numpy's Panda and Matplotlib. Um, and I'm gonna repeat this at the end of the session as well, but just a reminder, this is going to be actually the last session for our phase 1. And after this, we're going to be getting right into the AI side of the program, into phase 2. So that's super exciting, and congrats to everyone who got through phase 1. It's super exciting, and it's going to be some really useful information for you and super helpful in phase 2 here. So without further ado, I'll just let Sam take over and finish up on his talk on Numpy's Panda and Matplotlib. So I'm just going to make you co-host so you can speak.
Thank you so much, Andrew, for the introduction and all. Good to see everyone here. Actually, I see a lot of people here. I don't know what the weather looks like for you there, but I'm here in Vancouver, and it's actually getting pretty cold here too. So I hope you guys are warm and cozy, ready for like another session of basics with Numpy, Pandas, Matplotlib, and all that kind of stuff. Before we start, do you guys have any questions? Did you guys go through basically the contents of the previous session that I shared with you guys? Did you review the stuff that we talked about? Yes, no, thumbs up, thumbs down. You can put your comments in the chat. I want the session again to be a little bit more interactive. So please share your thoughts in the chat. Today's agenda and today's session, it's not going to be too long. We're going to talk about pandas, again, Matplotlib. We're going to talk about one basically case study. And I just want you to get on board how you can do basically scientific analysis in Python using Jupyter Notebook. Once you get into, again, more advanced stuff, like your project is going to get changed. For example, you're going to work with, get into, I don't know, machine learning, deep learning, and all those subjects. But again, the format would be the same. The way you would look at different things and you try to do analysis and you try to actually ask questions and come up with answers. So one thing that I want you to pay attention to is how everything is structured and how you can ask questions and go about answering those questions. Is that clear to everyone? So again, just to review and refresh your memory, last session we talked about NumPy, different operations that you can do using different basically methods of NumPy, how you can basically load different tensors, matrices, arrays, how you can basically use indexing to access different elements of an array, and of course doing different operations. So we talked about all that kind of stuff. Broadcasting was really important. And again, just like a pop quiz, just to make sure you guys have reviewed the previous, basically the content of the previous session. What does shape do? Again, what does the method shape do when you apply it on a NumPy array? Anyone can put in the chat. Okay, it tells you about dimension, displays the dimension, good answer, says dimension. Okay, that's good. So it seems we're all listening and ready for the new session. Okay, so this session we're going to talk about another library, very useful library called Pandas. We use it mostly for basically representation of data in a CSV format or Excel format, I would call it. So remember when you were doing, again, if you're familiar with Excel or like CSV files, you have columns and rows. And basically, previously, many people were used to just like work with Excel files, Excel sheets, and basically load those files, look at the columns, look at the rows, do manipulation inside each cell. But with Python and different libraries that they provide, basically many people just moved from all those spreadsheets and now they're using these libraries. So one of them is Panda. Similar to Numpy, Pandas is one of the most widely used Python libraries in data science. Pandas provide in-memory 2D table object called data frames. So again, if we hear data frame, Panda data frame, you know, it where it comes from. It's like a spreadsheet with column names and row labels. We can import and use it exactly like this. Import pandas as PD. So again, as I mentioned in Python, whenever you want to use a library, we start importing different libraries, right? So for example, with Numpy, we add import Numpy as NP. So again, NP was just like an alias because we're a little bit lazy and want to use shorter names. Instead of just typing Numpy, we can now use NP. The same with pandas. We can just like use import pandas as PD. Again, PD is an alias, just to make the name short. And this is one example. Before we get into the use, basically case study.
Right, can you share your screen?
Oh, I'm sorry. I didn't actually share my screen. Thank you so much for bringing that up. Let me share my screen. There we go. I was all the time. Can you see my screen now, Angelina? I think it was Angelina.
Thank you. Perfect.
Thank you. Yeah, no worries. Thank you for letting me know. I know some people are not sleeping now, just listening to this session. Okay. So we talked about Numpy and stuff like that. So today's session, actually we're going to cover pandas. So if you look here again, when we wanted to use different libraries, we would use import keyword. So we would say import this library, and we would give it an alias. So again, alias would just like make the name shorter for us because we're lazy and want to use shorter names. It's the same with pandas. So we use pandas, and usually the basic alias is PD. So import pandas as PD. And again, before we get into the case study, I'm just going to give you some examples how data frames are created. Again, data frames are usually like a 2D spreadsheet with columns and rows. So here's one example of pandas, how you can use a data frame. So again, PD, all you need is this data frame method. And then basically data frame, you gotta be careful because these two are uppercase. D and F, they're uppercase letters. And again, in Python, I told you uppercase and lowercase are of great importance. So if you use basically if you use a lowercase alphabet or just basically a keyword, and that method doesn't exist, then you would get an error in Python. So you got to be careful about these cases. Sorry, just let me make sure. Okay, excellent. Just want to make sure my thing is not going to run out of charge. So again, you also got familiar with different data types. For example, dictionaries, lists, and tuples. Again, who can put in the chat? What was a dictionary? Do you remember? What were two main components of a dictionary, and how would you excellence key value pairs, right? And that was one of the basically important hash map. One of the more very important data types that you had and you could work with. So here again, when you want to define a data frame, use key value pairs. So here the keys are, for example, species, population, and the values for each one of these keys are different. So again, here the values are represented as a list that contains different values. So species, we have values, and basically this guy. And for population, actually this should be changed. Never mind, that's okay, just for the sake of example. So for population, again, the same thing. We have all these values represented inside the list for this specific key. So we got two keys, species and population. We got all these values. So again, the values 1864, 22,000, and 80,000. And you can also specify, so this was the dictionary. And basically could also, when you're using data frames, you can also specify the index. An index is also like a list of values. So when I run this, you can see we can actually look at this data like a CSV file with columns and rows and with the indexes that you have provided. So I mentioned that I want the index to be, for example, panda, polar, or koala, different basic species, and then basically the subcategory of them, so like a bear, etc., and the population of them. So this is just one example of how we can use data frames, Panda data frames. Is that clear to everyone? Okay, so now I'm going to give you like a brief introduction of visualization to Matplotlib and Seaborn, and we're going to get into the case study, and by doing the case study, get more familiar with different functionalities of Pandas and Matplotlib and Seaborn and stuff like that. So again, for visualization, you want to be able to basically visualize different charts. And in Python, you use either Matplotlib, which is another library, or Seaborn. So again, Matplotlib is an open source drawing library that supports various drawing types. You can generate plots, histograms, bar charts, and other types of charts with just a few lines of code. It's often used in web application servers, shells, and Python scripts. And again, in Python, we always use imports. So imports for the libraries that are not basically pre-built. So again, Matplotlib, or basically this visualization toolbox is one of them. So that's why we need to import it. So import matplotlib.pyplot, and again we give it an alias as PLT. So here is one example of how we can use it. For example, imagine we have these two data points. Again, who can tell me what's the type of this? What is this one called? What is the data format or data type? So it's a list, and inside the list we have different values, and these ones look to be integer values, right? Nice. Or you can also say array. It could be an array, a list, or an array of integer values. The same with y. So x and y. And I want to just like plot these two, basically these data points with respect to one another. So x here, 1, once x is 1, y is 2. So it's a line, right? And that's how I would do it. plt.plot, and I would give it like these arguments, x and y. And then I can also give it a title. I can basically assign label for the x-axis. I can assign label for the y-axis. And I can, so one important thing that you have to be careful is this line. So important. So plt.show would show basically this plot for you. And then if you want to save this plot, basically in the current working directory, that's how you would do it. Saving plots, you would say plt.savebig, and you would give it a name. So this could be anything. I can just like call it sam.png, or for example, example.png. And that's how you can save basically each plots and use them in your presentation. If you have a PowerPoint presentation or whatever you have. So that's one example. So line plots. We can also have a bar plot. So the beauty of Matplotlib is you would allow you to use different methods to accomplish different, to basically see different type of charts. So now I want to represent it like as a bar plot. So that's why I would use this method bar. And again, it would accept two arguments, x and y, and now I would have a bar plot. But that's how easy it is to basically plot different charts in Python. and then I want to have a scatter plot, for example. So scatter plot. In order to do that, then I would use basically the scatter method. And I would do the same, like I would provide it X and Y, and everything else is the same. And again, the important part, you have to use plt.show to be able to show the image. If I want to have a pie chart, I would do this, and I would give labels to each segment. And again, one pro tip, never use pie charts. Pie charts are gross. This is just an example how basically you can use pie chart, but usually it's really bad to use pie chart. I mean, if you're doing research or if you're doing a presentation, don't use pie charts. They're really confusing and gross. You can use bar charts, like a nice, or you can use histograms or other type of charts. So another library that we have is Seaborn. Seaborn is a little bit fancier. You can actually have nicer graphs in terms of basically the appearance. I love Seaborn compared to Matplotlib, but basically you can use them in conjunct, basically use them at the same time, Matplotlib and Seaborn. So again, Seaborn is an amazing visualization library for statistical graphics, graphic plotting in Python. It provides beautiful default cells and color palettes. And again, it's built on top of Matplotlib library. So underneath, you're using actually Matplotlib library again. And the way you would use it, you would use again import keyword. So import Seaborn as SNS. That's again an alias that I would use to make it shorter. Unless, for example, say I want to plot like a distribution based on some random numbers. So again, random samples. You remember we talked about this stuff, right? In the Numpy session of the previous session that we had. So NumPy.random state. So you would assign like a random state. So your experiment becomes reproducible. And then I am going to basically generate 100 sample points from population that would be representative of a normal distribution. And then I'm using this plot method of Seaborn, which would basically plot the distribution of these points, random points that are generated from. And there we go. So again, just an introduction to Matplotlib and Seaborn before we get into the case study. Is everything clear to everyone? Do you guys have any question? Okay, excellent. So now the case study. Usually when you're given a case study, you they would provide you with the context, the objective, or sometimes you have to come up with the objective. So you go and ask, for example, your collaborator, or for example, the person who you're working with, or your manager, or whoever that person is, to define some of the objectives and start doing the experimentation. And use some of the libraries that basically we studied to answer to some of the questions that you have. So here, the context is this. The movie rating system that film buffs know today has been around for example, over 50 years. Over the years, the cultural standards and norms have changed, and so have movie ratings. However, even today, the process of rating a film remains a closely guarded, basically industry secret. So what are the objectives? So MovieLens is a company in the internet and entertainment domain that has an online database of information related to films, television series, online streaming content, including cast, production crew, trivia, ratings, and fan and critical reviews. You've been hired, for example, as a data scientist for the company. You've been provided the following 3 data sets, asked to carry out a detailed analysis of data and come up with some meaningful insights, which will, for example, help the company to address their users in a better way. So again, we have 3 data sets. The first important fact is you should have a data set or a collection of data sets, because without data points, you can do basically experimentations or can do any of the stuff that we talked about. So we're provided with these 3 data sets, which are in a CSV format. And again, another important point, you should get familiar with the data that you are provided. So for example, you're provided these 3 data sets, you should know what they are, or at least you should ask for the information about them. So for example, movie.csv contains information related to the movies and their, for example, genre. And it has basically different columns, which we will get into. For example, we have movie ID, movie title, release date, and of course, the genre of the movies. For example, action, adventure, animation, etc. We have another dataset, user.csv, contains information about the users who have rated the movies. And we have these columns: user ID, age, again, gender, occupation, and zip code. We have ratings.csv. So again, another data set in a CSV format. It contains information for ratings given by the user to a particular movie. So again, one of the first steps to carry out in any type of analysis or experimentation is to import necessary libraries to do what you want. And again, you would basically import the libraries at the top of your notebook. You execute them once, and then you can use them basically in the lower cells, wherever you want. So here, basically, we import the 2 main libraries that we got familiar with, Pandas and Numpy. And here, I'm reading the data set. Again, another important point, you should have these data sets already loaded in your, for example, if you're using Google Colab, in the specific folder of yours. Again, here, I put the basically these 3 files inside this folder, content. By default, Google Colab would read from this folder. So you can see I have this user.csv, ratings.csv, and movie.csv. If we don't have these 3 CSV files uploaded here, you will get an error. So if you're getting an error when you're loading the file or reading the CSV files, you have to look for 3 data sets under this folder. So that's about that, and that's how we read a CSV file. That's actually very easy, and with 1 line of code, you can basically fetch each CSV file and read them. So here, PD comes from Panda, right? The alias for that Pandas library, and we use this read.csv method to read this dataset. The same with users.csv and ratings.csv. So when I run it, you get this check mark, which means that you've read the datasets correctly. So again, look how the notebook is structured. It's really, again, important to know how you can structure your notebook so then you get confused, and also you answer the individual questions of yours and follow the objective. So here, for example, we read the data set, and then we go for the data overview to see how it looks like. The initial steps to understand any data set is to observe the first few rows of the data set to check whether the data set has been loaded properly or not. We want to get information about the number of rows and columns in the data set. And we want to find out the data types of the columns. So again, data types are really important. You have to get familiar with data types inside your data sets or data set or data sets, to ensure the data is stored in the preferred format and the value of each property is as expected. And we want to check the statistical summary of the data set to get an overview of the numerical columns of the data. So how would we do that? So again, we have 3 data sets. Again, movies.csv, users.csv, and ratings.csv. And we have a method called head. And that's very convenient, and it's like one of the important methods that Pandas data frame would provide you. It would give you basically the top 5 rows of your data set that you read, so you can quickly, look at the columns and rows and make sure the data set is properly loaded, and just look at the data types. So here you can see it's like a CSV file, right? We have different columns. We have user ID, age, gender, occupation, zip code. Who can tell me what's the data type of this column? Gender. Again, it's very simple. We got familiar with different data types. It's character or string, right? String value. So this, for example, look to be an integer, but we got to check to make sure this basically is integer. And it's not float. User ID. Again, this looks to be an integer type, but we got to check using a different method that I'll basically describe shortly to make sure there's no hidden floating points after. And of course, zip code. We want to see if this is a character or if this is a string value or if this is, for example, an integer value. So we're going to check all this stuff. So right at the first glance, we see the user dataset that has been loaded properly. We see that, for example, the column gender has values as male and female. So you see, for example, we have only two distinct values for this column or this feature or attributes. Usually, again, when you get into the machine learning concepts or deep learning concepts, we would define these ones as attributes or features of a data set. So just like to give you an idea before you dig deeper into those concepts in the feature sessions. And then we can also observe that users are from different occupational background, like for example, technician, right? Or we have writer or like other. And also the column zip code represents the area where the user is residing. So again, we want to understand the shape of the user dataset. I told you shape. You use that when you were using Numpy. So you can use it with Pandas as well. But that's the beauty of some of these methods. So again, the shape attribute will help us to get the number of rows and columns. Again, this is highlighted this sentence. It's really important to know the shape of your data sets, the dimension. So you know, for example, you have 943 rows and 5 columns. And you put your observations here as part of the bullet point, just like follow along. And of course, a more systematic way of checking types is using info, users.info. It's a very powerful method that will just like very easy to use. Just one single line of code, you can get the type of your features, values of your features or attributes inside your dataset. So when you do that, user.info, you can see, for example, user ID, you have 943 record of them. None of the values are missing. So again, not null means there's no missing value or empty value in any of those cells. Everything is existing. And the type is integer int64, age the same, gender is an object, occupation is an object, and zip code is an object, string or character. And again, we have 943 rows, and none of the values are missing. And if for some of you who are actually more interested in the memory usage, you can also get the memory usage of, for example, this data set, which for this one is very small because we're using a small, basically data set. It's only 39 kilobytes. Sorry. So now the next important part, we want to get the statistical summary for the user data set. So now we want to get more statistics about the values of the data set. So another very important and powerful method of Pandas data frame is this describe function. And you would often use them a lot. You use this method a lot. So when you call this function on top of each attribute or each feature of or let's talk about the data set itself. When you call this method on top, basically on top of the data set that you've loaded, it gives you all the summary statistics that you would need for example, different features of your data set. So for example, the user data set, the user.csv, has only 2 columns, user ID and age. I told you we have 3 different data sets. We have movie, user, and ratings. And here we only check user data set. You can do the same with the other ones. For example, you can ratings, we didn't check it, but if you want to do the same, you can do the same. You can just to make sure it's loaded properly, we do this, and you would see, for example, for ratings, you have different values, attributes, or features, or columns. We have user ID, we have movie ID, rating, and timestamp. And another one was which the movie basically. So again, movie that's head. And again, you get movie ID, the title of the movies, the release date, and different genre. So action, adventure, animation, and so forth. We have so many different genres. And if you look at the values, you would see they're represented by 0 and 1. 1 means, for example, this is animation. And for example, if the value is 1, it means that that column is active, or the genre of that movie belongs to that specific column. So for example, Toy Story is not adventure, so that's why you see 0 here. But it's an animation, you see a 1 here. It's also children's, you would see 1 here too. And could be a comedy, so you could see 1 here as well. But all the other values are 0. The same with, for example, this movie, GoldenEye, you would see is an action, so you have 1 here. It could be an adventure, so it's 1 here too, but it's not an animation. It's not children's, or it's not comedy. It's not a crime movie. So you can see 0 in all the other, for example, columns, value for all the other columns. It's also a thriller, so you can see 1 here as well. So just like by looking at using this head method, you can quickly get an understanding of different data sets that you have. So now we want to understand the shape of the user data set. Again, we did this, we got the info, and we also got the summary statistic of this. The summary statistic is only for numerical columns. That's why you would see these 2 columns here, because only these 2 columns are numerical. It has integer, like values that are of type integer or float. So these are numerical columns. All the other ones were objects, right? These were objects, or like string, or we can say character. So you can see the age, the mean is like around 35, 34. You can quickly see the standard deviation of 12. You can see the minimum age is 7, and the maximum age also here is 73. So quickly you can see the mean and max. And you can see the percentiles. 25th percentile is 25, 50th percentile is 31, 75th percentile is 43. So you can quickly, get the important summary statistics of that specific data set. And you can, of course, put your observations here. We can see from the age column that the average age of a user who have rated the movie is 34 years. The age of users ranges from 7 years minimum to 73 years maximum. And again, this one is not meaningful because it's a user ID, even though, for example, we get summary statistics for that, but it's meaningless. You can't interpret that. The main, basically, column that you would use for this summary statistic is the age. And again, we do the same process for each individual data set. And again, we put our observations as part of like a bullet points underneath. So here is for movie data set. We just like looked at it above. Here we have it again. We get the shape. We have 1,680 rows and 21 columns. And then again, we get the info. So you can see movie ID is integer 64. There's no missing value. Movie title, object, These two are objects or characters or just string. You can call it whatever. Again, all these ones are numerical columns. They're all of type integer 64. These are like the 0 and 1s that we see here. And of course, the memory usage, 275 kilobytes. You can, if this is important to you, we can look at it here too. I see Katrina has asked a question. Does the data have to be in this specific case? Yes, Katrina, it should be in a CSV format. Why? Because we basically read them using this read CSV. But if you have an Excel format or any other format, so like Numpy array or anything like it, you can use another method of Pandas to load it and convert it to a CSV or data frame, not a CSV file, a data frame format, but then all these ones would remain the same. So you can still use all these methods. So in this specific case, since we had CSV files, yes, we can fetch them using this way, because you can see we have read CSV. But if you have an Excel file, there's also read Excel. If it's a NumPy array, you can load it as a NumPy array and say pd dot data frame, convert it to a data frame. For example, let's say X, and then give it a name. And then you would have a data frame that you can apply all these functions on. Does that make sense, Katrina? But yes, that's why it's really important to just look at the type of the data that you have. In this case, we had the CSV, so we did this. So moving forward, we do the same thing with movie. So we understood the number of rows and number of columns that we had, the information about it, and the summary statistics. So we look at the summary statistics of this, and now you see, because we had more numerical columns, right? So we can see, for example, for let's see, the statistical summary of movie ID column will not, again, this is meaningless, so we're not going to use it a lot. And also these ones might not be very meaningful, except for the count. So we have, for example, 1680 number of action items, the same for adventure, the same for animation, which means that none of the values are missing. And I guess we had another data set that I haven't mentioned here, ratings. So you can do the same thing with ratings here. All you need to do, so these three functions, head, info, and describe. And of course, you would basically put the information that you basically gained or acquired by looking at the summary statistics in form of bullet points to answer some of those questions of yours that you have. So now the next step is moving to EDA, exploratory data analysis. So you see how we're just like flowing. The flow is like, we read the data set, we got like the basic understanding of the data sets that we have using different functions of Pandas. But now the next step is to visually check for the data sets, like anomaly detections, like anomaly or outliers or something out of basically ordinary. To just like, visually get an understanding of the data sets that we have. And for those, we use Matplotlib or Seaborn. And we call it ADA, Exploratory Data Analysis, which is an important step in data science. So again, Matplotlib and Seaborn libraries can help you to quickly apply visualizations and see how they look like. So for users data set, we had this age column, right? So that's another way of accessing a specific column of a data set when it's loaded and when it's read as like a Pandas data frame is by just doing this. So let's we have this user data set, and I know the user data set has basically different columns. So for example, one of the columns was age. That's how I can access it. Say access the age column from this user data set. I'm gonna basically run it. It will give me the values of that specific column. So that's how I can access basically different columns of a data set when it's read, like a Pandas data frame. Does that make sense? And here, in order to plot that or visually check for it, I would pass it directly to this plt.hist. I would say, okay, give me the histogram of the age of the users. And that's what I would get. And you would see it's like close to a normal distribution. It's not a perfect normal distribution, but it's very close, right? It's a little bit skewed. And we checked the mean age was 34, right? So you could see it here in this bucket. I can see the count of them. So if you go up, describe also gave us the that information right here. So mean was around 34. And we also got the count of them. And you could also visually check for that. Another very interesting basically plot is the correlation plot. Like relationship between each individual column. For example, column 1 versus column 2. Do they have any direct relationship? Does, for example, increasing the value of column 1 would lead to an increase in the second column, or would cause a decrease, or no? There's no basically direct relationship between these two. So again, one way to do that is using this correlation function. So you know, we had this movie data set, right? You can directly apply this CORR, which would stand for correlation. So correlation method on top of this data set. And it will give you this correlation matrix or correlation data frame. And you can also have a visual view of that. Before moving to that visualization, look, movie ID and movie ID has a perfect correlation to itself, right? It's like each individual variable has a perfect correlation to itself. So that's a rule of thumb. So that's why you would see 1, 1, 1, 1 on this diagonal line. So action and action. So action to itself has a perfect correlation. But now if you want to see the correlation between this genre and adventure, so action and adventure. So that's how we can actually look for it. Or, for example, animation and action. But these are not actually meaningful correlation, right? That's why the correlation is not that high. And even though if it's negative or positive, but they're not meaningful sometimes. So again, it's up to you to have a correct interpretation of the results. So it's your job to look at it. That's why it's called exploration data analysis, and see if there's a meaningful correlation between each individual variables. And another way of doing that is using this correlation map. And now I'm using Seaborn. So again, I'm importing Seaborn as SNS. SNS has this heat map method, and I can basically pass it this correlation matrix that I created here to this function. And again, you don't need to worry about these ones. By default, for example, this would specify the color, or if you want to have annotation, like the labels on the heat map or not. Usually they're set like this, and people usually don't change it. But you can see how it's basically used. And of course, if you want to change the size of your figure, you would set it here. plt.figure, fixed size, 15 by 7. And here you have like a better visual way of looking at the correlation map. So you can see one perfect correlation, a variable to itself, and like these ones, for example, this has a negative correlation. It's not as strong though, right? It's very weak. It's a weak correlation. Usually correlation from 80% and above is considered high. But again, this is different in each individual field. For example, in medicine, you got to be sometimes 90, some 95% sure. So with a confidence of 95%, then you would say it has a correlation. Anything below, for example, 90%, you would consider as a weak correlation. But in marketing, in business, in all the other aspects of, for example, industry, usually 70% and above, 80% might be considered as like a significant correlation. So again, it's up to you to interpret those stuff based on your domain expertise and all that kind of stuff. But we're just checking the tools and how you can do those type of stuff. Do you guys have any questions so far? Okay. Okay, moving a little bit faster to get into the more interesting stuff. So again, ratings, we talked about the head, we talked about the shape, we talked about the info, we talked about the describe, and now we're going to answer different questions. We want to, for example, answer this question: how many movies belong to a particular genre? So we had seen earlier that a particular movie can have multiple genres, right? So we want to investigate a little bit more, see, for example, how many movies can belong to a particular genre. We can use movie dataset because it has all the information that we want, and we just want to analyze it, just like do some aggregations on it to answer this question. So movie.columns, again, this is another method that if you applied on that specific dataset that you would read, it would just like print all the columns inside your dataset. So you would see you have all these columns inside this movie dataset. But in order to make everything easier, I go and just like create this list of values from this, like the list of genres that I'm interested in checking. So I create this list of string values, and I would assign this to this variable called genres. So you can see that we have 18 genres now in this list, and of course in our data set in general. And what I want to do, I want to get a subset of my movies data set based on these specific genres that I have and see how many of them I have. So that's how I do it. I would say from the movie data set that I have and I read as a CSV file and I have it as like a Pandas data frame, get this subset, get only these features or columns, these genres that are specified here, and sum the values that they have, like because they were 0 and 1s, right? Because I want to get the count of them. And axis 0 and axis 1. Who can tell me what was axis 0? What was axis 1? Like sum around a specific axis. What would it specify? Along rows or columns, right? So I just want to see 0 axis is row and then 1 is column. Great answers. And also I see one question. Yash is mentioning, yes, the notebook would be available to you. It's actually part of the same notebook that in the previous session, I forgot the name of the guy that he basically shared with you with Dr. Maliki, who was working with Dr. Maliki. I'll reach out to him to make sure it's basically shared with you guys. So that's basically how you can get the count of them. So now you can see we have 251 instances for action. We have 135 instances for adventure and so forth. So we got, for example, 251 movies for action, 135 movies for adventure and so forth. Another important function that you can use is sort values. Now you have all this stuff, but it's not sorted, right? You want to have them, basically, you want to sort them from highest to lowest or lowest to highest. Again, Pandas data frame would basically give you a method that you can easily do that, and that's called sort values. So the way you can use it is this. So that's your data frame. For example, your ratings data set or your movies data set. And then you would apply this function. And this is the column or list of columns you want to sort by. And then here, ascending, here's a keyword or parameter to that function that would basically specify if you want to have the sorting from descending to ascending or vice versa, highest to lowest or lowest to highest. And you would notice this in place parameter, which would basically indicate whether you want to operate directly on the original data frame or on the original data set that you loaded, or you want to have a copy of it and then apply that sorting on top of it. And by default, it's false. So again, I do the same. I have the same line of code. I would get a subset of this movie data set. I would sum the values because I want to get the count of them. And now I want to sort them. So you would read it again from left to right, operation-wise. And I want to have it from descending. That's why ascending is false. Highest to lowest. That's why you would get this nice sorted values. So drama, you would see, has the highest. So movies are distributed across 18 genres in total. So these are your observations or insights that you would have that you would put here. We can observe that drama genre has the highest number of movies with 725 in total, followed by comedy, which is like 505. And again, a fantasy genre has the lowest number of movies with 22 in count. So you can quickly get some insights into your data sets. So let's answer another question. Can we find the movies that have more than one genre? So now we want to find movies that had basically more than one genre. So again, as discussed earlier, a particular movie can have more than one genre. In order to do that, again, first, we would create a new column name, and we would name it this, name of genres. And that's how you can create a new column in, for example, your Pandas data frame. So I had this movie data set, right? I want to create a new column with this name. That's how I would do it. So I would say, okay, create this new column inside my movie data set and assign this value to it. So now let's see what I'm actually doing here. I'm trying to access all the rows and the specific genres that I have, the specific columns of basically genres that I had, right? Action, comedy, etc. And I want to get the values across each row. What was this one? Again, access one. All the columns, right? Column wise, because I want to sum these numbers. So again, access one parameter is used to get summation of the values. Again, the row, while access one, access zero is used to get the summation of the values along the columns. Well, I'm sorry, I said it the other way around. So again, access one, because I want to basically get, I want to see how many genres they belong to. I want to sum across the rows, all the rows. And then if I want to go for a particular movie, I would do the sum across all the columns. And then I would specify, for example, zero here. But here, I want to actually go along the y-axis. So again, just to get, just refresh your mind, movie data set was like this, right? So we had the movie ID, movie title, release date, and all these genres. And then now I should have a new column called number of genres. And I created that here. So you would see it here, basically. Does that make sense? So again, I did the summation. So 1 + 1 + 1, 3. So again, Toy Story belongs to 3 different genres, right? 4 Rooms belong to basically has only 1 genre, so it's 1. So summation along this axis. So that's why I mentioned axis 1 here. Does that make sense to everyone? Okay, so now I can do more fancy stuff with it. I can say, now I have this new column here inside my data frame. Let's filter based on what I want. Let's see, for example, let's pick up the rows where number of genre is more than 1, so that we can find the number of movies with more than 1 genre. I want to filter out these ones that have basically only 1 genre. I want to see the movies that have more than 1 genre. So I use a conditional sentence or syntax in Python. So I would say, give me a subset of movies data set with this condition. I want the values of number of genre to be more than 1. So give me instances or rows inside this, for example, movie data set that has values more than 1. Give me a subset of those. And when I run this, then you would see I would get a subset of this original data set, but with this column that has values more than 1. So we see there's no 1 here anymore. We have 3 number of genres, 2 number of genres, sometimes 5 actually here. Stuff 5 too, right? And that belongs to, for example, Muppet Treasure Island. So you can see, you can do these type of analysis. And if you want to see how many instances there are, again, you can use shape function. So again, the same code, the same line of code, but I just added the shape function to it. And I see I have 849 instances of basically, I have 849 examples or movie titles that belong to more than 1 genre. And you can put your observation here. Originally, I had 1680 basically number of movies. But the subset of those is just like 849 with this condition. Does that make sense? Is that clear to everyone? Again, don't worry about the syntax. It can get a little bit confusing, but once you get the concept, and since you would have access to the notebook, when you play around with it, you would understand it more. The syntax would basically come to you naturally. You would learn it. But if it looks a little bit confusing, especially with all these square brackets, don't worry about it. I just want you to get the concept and the stuff that you can do with Pandas data frame. And of course, how we can do like an experimental or data analysis type project in Jupyter Notebook. So let's go to some more, like a little bit fancier questions or analysis. Can we find the genres that are most liked by the users? So you remember we had different data sets, right? We had the ratings, we had the users, we had the movies. And each data set had specific, basically columns. One thing that was common between all these 3 data sets was basically the first column, the ID. So if you go back to the data sets when we read them here, we would see, for example, user ID is the same in these 2 data sets. Like ratings has the user ID, and user also has the user ID. And if you also look at the movies, you would see that, for example, between ratings and movies, you would see we have 2 mutual columns. Movie ID exists in this data set, and movie ID also exists in this data set. But it doesn't exist in the user. So between each individual data sets, we have one mutual column, right? So why is that important? What can we do with that? Again, when you're given multiple data sets and you want to do data analysis or just like experimentations on them, what you want to do, you want to sometimes combine multiple sources of information into one. You want to merge information from multiple sources so you can have one huge table and then answer more questions. In order to do that, you should use one mutual key, one key that's the same between two different tables, so you could merge them. For some of you who are familiar with SQL, MySQL, and databases, you might be familiar with the concept of merge. So again, the same concept of merge, sharing information between multiple sources or data sets into one. We also you can do that in using Pandas data frame as well, in a very easy and neat way, and we'll talk about it shortly. So again, the question that we had and wanted to find answer to, we wanted to see if we can find the genres that are most liked by the users. So again, as we've already seen that the information regarding rating is present in the ratings data set. However, the genre columns are present in the movie dataset. The only column connecting the two datasets is the movie ID column, the one that I showed you, which are basically the same, the two datasets. We can merge these two datasets into one and then do our further analysis. But before that, let's talk about merge and what the different types of merging and how they work. Any questions so far? Okay, good. So we have different types of merging or joining or basically concatenation. Panda provides various facilities for easier combination of different data frames or data sets. One of them is the inner join. So again, the name tells that we want to fetch information that are mutual between two different data sets. So for example, we have this data set on the left, which we will call it left table. We have this data set on the right, we will call it the right table, and you see they have different columns. We have this index column, which is mutual, they're the same, the ID is also the same. But we have these two columns in here, which basically don't exist in the right table. But we want to merge these two together to have like the mutual information, the information that exists on both of this table into one. The way we do it is like this. We would say merge the left and right on basically this ID column. So we used one mutual key inside these two tables to merge them together. After merging, you would have this basically table now. So now you would see ID is here again, but we have all these columns included. We have the subject from this table, we have the name from this table, and we have the age. So we just like combine them into one. There's another type of join, which is called left join. So again, this is the left table. It has specific columns. Again, we have the index column, we have the customer ID, product name. And we have the right table with the index column, customer ID, and state. So again, product doesn't exist here. Left table, when you're doing the left join, is your main source of truth. So again, as the name tells, if this is your left table and you're using left join, you would use this table as your reference. So you would include everything that exists in this table, but on top of that, you would add information from the right table to it. So the way you use it is like this. Use the left table as your source, and then also your right table. Merge on this mutual key the column that exists in both of these two tables, which is called customer ID, and the type of join. How do you want to join it? Left join. And then you would end up with this table. So now you would see we have NaN values or missing values. Why? Because state was missing from here. So when we merge this one on top of this, some of the values that existed here, basically don't exist in this table, and they're represented by NaN. So we have, for example, for California, we have the information here, but there's no California here. So again, we have California here, but over the state here is NaN, missing value, or here the same. So there's another type of join which is called right join. Again, I'm not going to go through it because it's exactly the same way as left join works, but the other way around. So you would use your right table as your source, and then you would move all the stuff from your left join on top of it, a left table on top of it. Usually you would use left join, so you don't use right join. If you use left join, you wouldn't use basically right join. And we have the outer or full join, which basically merges everything. So like you might end up with duplicates. You would merge, or you would concatenate all the information from this table and that table into one. So again, you have left table and right table, and this how now you would basically specify by outer join. And again, you would end up with this again full data set which has information from these two tables. So now the way we're going to do the joining for our own case to answer the question is using the left join. I'm going to say my movie is my main source of truth, is my reference table, and I want to merge the ratings table on top of my movies table. So that's how I would do it. I would say, again, I have this movies table, merge ratings on top of it, and merge based on this movie ID that existed between those two tables, use them as like the key, or how you would join these two. And this is how you would specify the type of join that you want to have. I want to have a left join, so I would do this. And when I do it, now I would end up with these three new columns. User ID, which was missing initially from my movies table, ratings, and timestamp. So again, as we can see, user ID, ratings, and timestamp are now added to the end of the data frame. So now we can do basically more analysis. Does that make sense to everyone? Okay. So again, we type, just to refresh your memory, we had all these genres of movies. We have action, adventure, and so forth. Just to, again, give you some functionality of Pandas data frame, I put this example here. We will run a loop across the, because we merge these two together, right? And now we end up with this one single table, again called df merge, which has information from the two tables that we had, movies and of course ratings. So now what I want to do in order to find the genres which are most liked by the users, we can find the average ratings of each of the genre and then compare among basically each one of them. So again, in order to find the genres which are most liked by the users, we can find the average ratings of each of the genre and then compare among them. For this, we can again use this genre list. So we had this genre list. And we will run a loop across the merged data frames for the columns that are present in the genre list. Whenever a particular genre is found to be found to have the value 1, we will extract it and we would just like add it to this basically average variable. And you would see how it would work. One example, just to show you how, for example, this work, when you use conditional statements using data frames, you would end up with something like this. So again, what's if I want to mention what's happening here, I'm just like trying to get a subset of this merged data set that only has the value of, you know, action set to 1 for that genre. So you would see we have false and some instances of true. So if it basically is giving me the indexes of the rows that have basically the values 1 for this action column. So I can use this to basically loop through this data frame and find basically genres that have action, that have basically value 1 for action. So again, for I in this genre, like the list that I had here, I look through each genre and I say, okay, I had this merged data frame, but then find instances, rows that have value 1 for that specific genre, meaning that that basically category exists for that specific movie title, and then get the rating and calculate the mean for me, the average for me. Again, I know this can be a little bit confusing for you guys, but I just want you to get the concept. So if you don't fully understand this, don't worry. If you're confused a little bit, don't worry. I just want you, want your eyes to get familiar with these syntaxes. Once you play around with them, it would, the missing pieces of the puzzle would fall into place. You get more familiar with how you can basically do looping and indexing using data frames. So again, don't worry if you don't fully understand this yet. So again, when I do this, after merging, I notice that I have, for example, user ID, ratings, and timestamp added to my data frame. And then one way that I could answer this question was by looping through each individual genres, finding values 1 for that specific column of genre, and calculating, getting the rating, and then calculating the mean for that rating. And there we go. We can actually see the average rating for each a specific genre across all the rows. So for example, you can see action has this average rating of 3.48, adventure has 3.5, animation has 3.5, and so forth. But what you would notice is like these ones are not sorted. So you can use that sorting function, sort value, to sort them based on highest to lowest. So again, I'm going to talk about some more methods that you can use with pandas to avoid, for example, these for loops. Again, these are nice to know, but again, if you didn't understand this part fully, because I know this can be a little bit complex for some of you that might not have much background with pandas, don't worry or don't panic. I just want your eyes to get used to seeing these type of calculations. The more you play around with these these studies, and then you run them in different cells, the more comfortable you'll become with using, for example, these methods. Do you guys have any questions so far before I talk about more methods in pandas? And we have 15 more minutes. I'll try to wrap everything up in 5 minutes, and then have like maybe 10 minutes for Q&A, questions and answers. Okay, so again, we have I told you a data frame is just like an Excel sheet, right? With columns and rows. There are different methods. When we read a data set using Pandas data frame, you will load the data set in form of a matrix, like a 2D matrix like this. But then you would have access to a lot of methods that you can apply to that data frame to accomplish so many different things. One way of looping through each rows and values of a data frame is using, for example, iter items or items. So for this, I've created actually a simpler example. So here I'm creating a new data frame. Again, I'm basically using a dictionary. I have these two keys, and I have these values for each individual keys. I have number of legs and number of wings. I have number 4 and 2, 0 and 2 for each individual basically keys. And then I have the index, dog and hawk. So I want to see whether the instance that I have is a dog or is a hawk. If the number of legs, for example, is 4, and number of wings is 0, then it's a dog. The number of legs is 2, number of wings is 2, then it could be a hawk. So again, this is one example, example 2. And one way I can loop through each item is using iter items. So again, you will see how it works. For index and content in this data frame, dot iter items, you can easily just like print the index and the contents. So the index, like number of legs, basically index here is the columns, and the number of wings, and the contents is just basically these the values basically. Dog is 2, hawk 2, and then dog 0, hawk basically 2. Another way of doing this is like using iter rows. So again, as the name tells, we iterate through each individual row. So we have the same data frame and we iterate through each individual row. And there we go. We have basically this row, number of dog, number of leg 4, and then number of oops, let me actually bring that up so you can see better. So we're using iterate row now, and then we want to print each individual row. So if you see, we have again dog, number of legs 4, number of wings 0, and then we go to the second row, hawk, number of legs 2, number of wings 2. So again, instead of using a nested for loop or basically for 2 times, you can use iter rows or iter items to iterate through each individual components of Pandas data frame. And then we also have basically iter tuples, which again, it would return the values in form of a tuple. So again, we have the same example. What I'm trying to do is just like using the iter tuple, and that's what it does. So it would print the index 2, dog, number of legs 4, number of wings 2, hawk, number of legs 2, number of wings 2. If I want to ignore the index, then I can set this to false. And then I can print this again. And then I would just like get the values. So I want to go through a more advanced, like as a bonus point, I would put basically some more advanced questions here. I'm not going to go through it because you might get confused, especially since I know some of you might not have that much background in Pandas or just like in general Python and stuff like that. But it's just like for you to play around with them. So again, I'll share this Jupyter notebook with you guys. I assume it's already shared with you. But again, I'll double check to make sure everyone has access to it. But you can go through like all the following questions and then try to do more practices. But just like to wrap that up, In the previous session, we talked about Numpy and all that kind of stuff, but the stuff that you can do with Numpy, reading arrays, doing indexing, and all that jazz. This session, we talked about another library called Pandas, which would read data sets and then convert them in form of like a 2D matrix, like an Excel sheet with columns and rows. And we talked about how we can easily use this method, read.csv, to read a CSV file if your data is of that type. Here, we talk about how we can basically use this method, read CSV, to read, for example, specific CSV files and do different analysis. We talked about head, how we can get, for example, a look, how you can have a look at your data set quickly and just like take note of different attributes, features, and so forth. How you can reshape your Jupyter notebook with the understanding, with your understandings of the data in terms of bullet points, these functions that we studied, like shape, info, describe, which would basically give you the summary statistic of the data set with mean, standard deviation, and all that kind of stuff. We talked about the Matplotlib and Seaborn, how we can use the correlation plot, heat map, and plots, and basically visually look at your data, and again come up with your interpretation. And then we also talked about merging, how you can merge different type of. We talked about sorting, how you can sort values. We talked about merging, how you can merge different data sets into one. And different types of merging here: inner join, left join, right join, or outer join, and do your analysis. And I think this is the end of the session. If you guys have any question or anything else, you can just like let me know.
Hey, great. Thank you so much, Sam. That was super awesome. I'll just give anyone a few minutes or a couple seconds if they have any questions to ask. So as I mentioned right before this call, this is actually going to be the last session for phase 1 of the program, and I just want to congratulate everyone for getting through the whole thing. I know learning programming can be a little bit intimidating at first, especially things like this with Pandas and Numpy, because it's very specific libraries that you're trying to learn here. And I know Sam mentioned this a couple times, but don't be intimidated if you're confused about any of the topics in regards to Python or about these libraries, because yeah, like you said, it takes practice to memorize all of these functions. And if you're ever really confused about this, this notebook will be a great resource for you. So if you ever have any questions, you can always come back and check as well. So phase 2 is actually going to be starting up. We're going to have our opening ceremony on Wednesday this week. And we're going to have a talk from a researcher over at Google who's going to give you guys some insight as well into what we're going to be learning. So that's great. I hope to see you all there. Is there any questions about the lesson today, or even about any of the logistics of the program? Yeah, I see Ash has your hand up. You can unmute your mic or just type in the chat.
Hello, can you hear me?
Yeah.
Hi, sorry, I just had some trouble accessing this session notebook. Is it possible for you to send it in the chat again so I can access it?
Yeah, just give me 1 second here.
Thank you.
Grab the link. And then Angelina, you have a question?
I had literally the same question, like how to access it. So can you send me a link?
Yeah. Okay. Okay, so this is going to be session 5. Just making sure that I'm looking at the right one here before I send the link. Okay, great. I have it here. Yeah, I just sent it in the chat. All right, was there any other questions? Okay, awesome. Well, in that case, I hope all of you have a great rest of your evening. Sam, is there anything else that you wanted to mention?
No, thank you so much, Andrew, for covering all the logistics and stuff like that and support on it. And yep, thank you guys for participating. Have a good one. Take care.
Bye, everybody.
Thank you. Have a good night.